All right, welcome back for the second piece of 2-4. So now that we've investigated all three forms of lines, now we're going to investigate parallel and perpendicular lines. So that's going to be our learning target for the day. Before we dive in, we got a little bit busy yesterday with all of those things, so I want to make sure to include a word problem, okay, for how these different forms can help us. So let's take a look at this. The office manager of a small office ordered 140 packs of printer paper. Based on average daily use, she knows that the paper will last about 80 days. What is the equation of the line in standard form? All right, so here we're talking about tracking. So here, number of days, and then we're using that to track the paper that they have left. Okay, so let's take a look at what this is telling us. So what it's telling me is on day zero, they're going to have all 140 packs of paper, right? And then by day 80, they're going to be all gone, okay? There's not going to be any paper left by day 80. So if I want to write this in standard form, well, again, given 2 points, what's the way that I can do this? Well, I can do this by starting in point slope form. For that, I actually need slope though. So subtract the y's, subtract the x's. So 140 over negative 80. Let's see what that as a reduced fraction is. So negative 7/4. Okay, so my slope is negative 7/4. Okay, so now, again, we always want to start on point slope form. It's always typically easiest that way. So y minus y value from the point, or from a point, I'm going to use this one, equals the slope times x minus x value from the point. So here is a point slope form equation. Okay, that's usually where you always start. But let's see what the end result is. End result is standard form. All right, so standard form, y equals, well, this is going to distribute. So negative 7/4 x plus, well, now we need 7/4 times 80. So negative 7/4 times negative 80, because I'm distributing that in, and that gives me 140. However, remember, standard form means no fractions. So I'm going to multiply all of that by 4 to get rid of that fraction. So I'm going to have 4y equals negative 7x, because it canceled the fraction out, plus, well, now we need 4 times 140. So 4 times 140 is going to be 560. Standard form means x and y need to be together, so I'm going to add that over. So there would be my standard form of that equation. Okay? And how many packs of paper should the manager expect to have after 30 days? Well, 30 days would be having x of 30. So I can plug that in, and now I can solve this. So 210 plus 4y equals 560. Subtract the 210. And then 350 divided by 4, about 87 and a half packs left. Okay, and again, that's based on 30 days. So when X is 30, it wanted to know the packs of paper. What is Y? All right, so again, just reviewing the skills we talked about yesterday. But let's focus on today, okay? So we're talking about parallel lines now. Parallel lines have the same slope, but different y-intercepts. So notice these two lines here, same slope, but different y-intercepts. They follow each other, but they never ever cross. Okay, that's going to become important in chapter 3 as well. So to find the equations of a parallel line, identify the slope of the line that you're given or line you're comparing it to, and then use that slope in a point slope formula using the new point. Okay, so write an equation for a line that's parallel to this line and goes through this new point. Well, if we want it parallel to this line, that means I need the same slope. So I need a slope of -2 and to go through that point. That sounds like a job for our point slope equation. All right, so y minus the y value from the point equals our slope times x minus the x value from the point. All right, and it says we can leave it in point slope form, and that's the form that we have it in. So we already have our answer. So again, it's not actually too different from what we were doing yesterday, right? Still finding slope and point and then putting it into the proper equation. The point is just this new vocabulary is going to tell us how to find the slope, okay? So what about this one? Line AB passes through points 2, 3, and -2, or -1, 2. What is the equation of a line parallel to AB that goes through 6, 3? Well, to be parallel to this line AB, to be parallel to it means same slope, right? That's what being parallel means. So first, we need to know what is the slope of that line, AB, okay? So the slope of line AB is going to be, subtract the y's, 2 minus 3, subtract the x's, -1 minus 2. So we're going to have -1 over -3. We're talking about having a slope of 1/3. Okay, so we want that slope of 1/3 with our new point. Okay, so we want a parallel, so we want to use that same slope, but now they're telling us our new line needs to go through this point. We have a slope, we have a point. Let's put it in point slope form with that new point. Y minus a y value from that new point equals our slope, x minus the x value of that point. So this is a point slope equation, okay? That's always where we start. However, look at what it wants it in. It wants it in slope intercept form, okay? So what that means is now I have to work on transitioning this to slope intercept. Slope intercept, remember, means solve for y, okay? So first I'm going to distribute this. So y minus 3 equals 1/3 x minus 6 times 1/3, or 6 divided by 3, leaves me with 2. Or again, you could use a calculator if you needed. Then I'm going to add that 3. Negative 2 plus 3 is a positive 1. This is my slope-intercept equation because now my y is by itself. So again, the big idea here is identify the slope that you need, then put it in point slope form with your new point, and then simplify if needed. Okay? Again, the big idea, you always need to be able to be fluid between these forms of the equations. All right, what about perpendicular lines? So perpendicular lines, they cross at a right angle, okay? And they have opposite reciprocal slopes or negative reciprocal slopes, okay? So what does this mean for us? Well, what this means is, first of all, let's talk about how do we find the slopes of the perpendicular lines, okay? Because that can be a little bit tricky in and of itself. So let's chat about that. So here's the slope of my given line, right? So its perpendicular slope, the slope of a perpendicular line to it, that new slope is going to be opposite and reciprocal. So the slope of the perpendicular line would be negative 1/3. What if I give you an equation like this? Well, now you can't see the slope yet until you get that y by itself. Okay, now that I have y by itself, here is the slope of the line. So I want the slope of the perpendicular line is going to be opposite, so that's going to make it positive, and reciprocal. All right, here, this line has a slope of, oh, whoops, not negative 1/2, has a slope of negative 2, okay? That's the slope of that line. I can tell by the graph. The slope of the perpendicular line, then, is going to be opposite, so positive, and then reciprocal. So its perpendicular slope would be 1/2. Here, we can calculate the slope between those 2 points. 2 minus 3, 0 minus 4. So negative 1 over negative 4, just going to be 1/4. So if I want the slope of the perpendicular line, it's going to be opposite, reciprocal. So 4 over 1, but I don't have to show the over 1 part. Okay, so the first thing is, can you identify the perpendicular slope? Okay, once you're good at that, then we can dive into the harder thing about making equations. Okay, so let's talk about forming equations. What is the equation of the line perpendicular to y equals negative 4x plus 2/3 through 8, 5? Leave in point slope form. Perpendicular means opposite reciprocal slope, okay? So right now my slope is negative 4. The slope of my perpendicular line has to be opposite, so positive, and reciprocal, so 1/4. So that's going to be the first step, okay? Identify what your new slope needs to be. You do that by identifying, are you talking about perpendicular or talking about parallel, okay? So I have my slope, I have my new point, so let's put it in point slope form. Y minus y value from the point equals our slope, x minus x value from the point. And this is already in point slope form, which is the way that they wanted it. So we are actually already done with this problem, okay? So again, just a lot of vocab. You have to track parallel versus perpendicular. You have to track what form your answer needs to be in. Okay, so a lot of language I need you keeping straight in this section. So let's just do a little more practice here, okay? So what is the equation of the line parallel to that line that goes through that point? All right, so parallel means same slope, right? The same m value. But I can't tell what that slope is yet, not until I get the y by itself. All right, so now I see I need the same slope. So the slope of my parallel line is going to also be -2. Okay, so let's start our equation. Y minus the y value from the point minus -2 gives me a +2 equals slope x minus the x value from the point. So this is my point slope equation. However, it says it wants slope intercept. So what that's telling me is I'm not done yet, okay? Slope intercept means solve for y. So I'm going to distribute that -2 and subtract that 2. And that is in slope intercept form. So that's going to be the end of my problem. All right, another example. So here, write the equation of perpendicular line to that one. So perpendicular means opposite reciprocal slope. Okay, so that's the first thing. So if my slope right now is 3, it means the perpendicular slope is going to be the opposite reciprocal to that. Okay, with this new point. All right, so point slope form, y minus the y value from the point is equal to slope x minus x value from the point. So this is my point slope equation. But notice it wants it in standard form. Okay, so standard form means no fractions and x and y are together. Well, that also means no parentheses, really. So let's distribute that. -1/3 times -9. So basically -9 divided by -3. Add the 2 over. So now I want to deal with this negative, or with that 3 right there. So I'm going to multiply this whole thing by 3 to cancel that off. Okay, I want to get rid of that denominator. Now I need to get x and y together, so I'm going to add that x over. And there is my standard form equation. Okay, so again, the things to watch for are the language parallel versus perpendicular and what form you want your answer in. Slope intercept, point slope, or standard form. All right, as always, a lot of good stuff today. So please make sure you have a lot of good material to write your summary on. So reflect on what we've talked about today, some of the highlights you think you need to know, and then come back ready to do your practice work.